So in this video we will continue with the tutorial. Okay, so let me write 5 example. Okay, so let me write down the question. The question says okay, consider the following homomorphism. So represent, okay, it says consider the following map or the following homomorphism defined as H from R3 to R2 given by okay, we don't even need that, x, y, z. We associate x plus y and x plus z. Okay, and the basis b, which is equal to 1 1 1 1 1 0 and 1 0 0, and d equals 1 0 and 0 2. So the first question is question 1. Represent the map. Present H. Map H. Present H. Okay. And the second question says represent. Okay. Find the representation of the vector v given by 2 minus 3 in D. Okay, so this is going to be our question. Okay, let's start with the first question: how to represent H. Represent Z T H. If you have watched the previous video, the definition of matrix representation of a linear map is as follows. So what we need, step 1, okay, we find the action of a H on each element of the domain basis. Okay, the action, and then we just concatenate those. First of all, we find the action of each element of H, the action of H on each element of the domain basis, and then we represent that action with respect to D. Okay, so step 1, find Then the action of H on B, on the B, the basis B, and B is here. So we need the representation, so the action of H on the element of B, if you want to. The element of B. Okay, so the first one is the action of H on 1, 1, the first element of B is, okay, is a 1, 1, the first element. So what does H do to that element? Is it takes the first component and add it to the second component. So 1 plus 1 is 2. It takes the first component and add it to the third component. So 1 plus 1 is 2. So that's the action of H on the first element of the basis B. Then the action of H on the second element, 1, 1, 0. Okay, it takes the first element, the first component, and add it to the second component. So we have 2. First component, add it to the third component. So we have 1. And the action of H on the third element is step 1 is 1, 0, 0. First element added to the second element is 1. And then first element added to the third element is also 1. Okay, so we have 2, 2, 2, 1, and 1, 1. Step 2. Okay, let me go to the next page because we won't have enough space here. Okay, so that's the first step. The second step, step 2. Represent those images. Represent those images. Okay, in G. So those images, if you recall, they are 2, 2, 2, 1, and 1, 1. So we have 2, 2, 2, 1, and 1, 1. We need to keep the order. Okay. When it comes to the element of a basis, the order does matter. So let's represent the vector 2, 2 with respect to the domain basis D. And just a quick recall for the domain basis is 1, 0, 0, 2. Okay, so here G is equal to 1, 0, and 0, 2. Okay, so representation of the first image is as follows. How do we represent a vector with respect to a basis? We equate that vector with the linear combination of the element of the basis. So we have C1, the element of our basis D, 1, 0, plus C2, 0, 2, equals to our vector 2, 2. Okay, so we have C1 equals to 2, and 2C2 equals to 2. That means C2 equals 1. Therefore, the representation, let me change color. The representation of 2, 2 with respect to D is C1, C2. So it's 2, 1. Okay, C1, sorry, C1, C2. And the representation is C1, C2. Now let's represent the second image with respect to D of 2, 1. That's my 2. Looks funny. True. So we take a linear combination of the vectors in D. So we have 1, 0 plus C2, 0, 2 equals 2, 1, our vector. So we have C1 equals to 2. C1 equals to 2 and 2C2 equals 1. That means C2 equals a half. Therefore, our representation is C1, C2, so it's 2 and a half. Yeah, sometimes we can write the basis later there, or we can just ignore it. Okay, so let's represent the last image. So representation with respect to D of 1, 1. So we have C1, 1, 0 plus C2, 0, 2 equals 1, 1. So we have C1 equals 1, 2 C2 equals 1. That means C2 equals a half. So the representation is going to be 1 and a half. Okay. So that's step 2. Now the last step is just concatenating those representations. So step 3, to find the representation of a linear map. Finding the matrix representation. So the matrix representation is going to be okay, let me write it here. Representation with respect to B, D of the map H is going to be what? The first representation is 2, 1. Then we write the second representation, we say it 2 and a half, and the third representation, which is 1 and a half. So this is our matrix that represents our linear map. Okay, so let's have a look at the second question. They say find the representation of V in D. And in the lecture you have seen that from this theorem, okay, that if we know the representation of a vector in the domain basis, and we also know the matrix that represents the linear map, then what do? We just do matrix vector multiplication. We just multiply the representation of V by the matrix representation of the map. Okay, so basically here you have the matrix representing the map, and then the vector representation, the representation of the vector in the domain basis, and then we just multiply the two together. Okay. So the second question is to represent the vector 2 minus 3, 1. So we want to representing the vector V, which is 2 minus 3, 1. So we want to represent that vector in D, in the basis D. Sorry, with respect to D, yeah. We want to represent that vector, the action, or find the action of H on V. So okay, so here is the vector we are going to represent, and yeah, let me here, I forgot to write H and H. Okay, so first of all we need to step one, find the representation okay, so, representation of V in B, the domain basis. Okay, so how do we find that representation? We take the linear combination of the element of B. The element of B are C1, 1, C2. The second element of B is 1, 1, 0 plus C3 of 1, 0, 0. Okay, equals to our vector 2 minus 3, 1. So we have C1 plus C2 plus C3 equals to C1 plus C2 equals minus 3, C1 equals 1. Okay, so that means here C2 is back substitution is going to be equal to minus 3 minus C1, which is minus 3 minus 1, which is equal to minus 4. And here C1 equals 2 minus C2 minus C3, which is 2 minus our C2 is 4, and then our C3, actually it's going to be C3 here and C1. Our C1 is minus 1, so we have a 5. C3 equals to 5. Okay, so the representation of V with respect to B is equal to C1, 1, C2 is minus 4, and C3 is 5. Okay, so that's step 1. Step 2 is step 2. Do the matrix vector product. Okay, here let me call so that's the representation. So the representation of the matrix. So what we are going to do is here, let me write it down fully. BD of H multiplied by the representation with respect to B of the vector. So I'm not very happy about the question. Okay, but I will explain it later. So we have our matrix. To find the representation of V in D, that's our question. So basically we are asked to find the action of H on V. Okay, to find the action of H on V. Okay, so represent the image of V. So I think I should write the question as find the representation of the image of V. Anyway, so find the representation of the image of V. Is more clear that way. So representation of representation of the image of the vector V in D, of course. We don't even need to precise that is in D, of course. Okay. So now I feel more convinced. I'm happy about the question. So basically we have our matrix, which was, if we recall, 2, 1, 2.5, and then 1.5. That was our matrix representation here. 2, 1, 2.5, and 1.5. So we are going to multiply that matrix by the vector 1 minus 4 and 5, and we will see the image of V. So how do we do matrix vector product? If you recall from the lecture, matrix vector product, we take the row of the matrix dot multiply by the column of the vector. Okay, so let's do it here. So the row of the matrix is there, dot multiply by the column of the vector. So 2 by 1 is 2, plus 2 multiplied by minus 4 is minus 8, plus 1 multiplied by 5, which is 5. And here the second element is going to be 2 multiplied by 1 is 1, a half multiplied by minus 4 is minus 2, and a half multiplied by 5 is 5 over 2. Okay, so the answer is going to be so here we have 7, we have minus 1, and here we have minus 1 times 2 is minus 2 plus 5. So it's going to be 3 over 2. So that is the representation. I didn't write it down. I should have written here. Okay, so even if the step 2, I should have written that the representation of the image of V. So here we have the representation with respect to D of the image of V equals to that. That was our step 2. Okay, so here I should also write it here. So the representation with respect to D of H of V equals that. So here is the final answer, representation with respect to D of the image of V. Okay, good. Now we can do a small check. Okay, let's check if that was correct. So let's check. We can just take that vector and see the action of H on that vector. Okay, So here we have our h. The h was defined as it takes x, y, z, and it associates x plus y and x plus z. Okay, so if we take the vector h of v is going to be equal to and our v, so v here equals 2 minus 3 1. Okay, and so h of v, it will take what, the first component added to the second component, so we have minus 1. The first component added to the third component, we have minus 1 3. So now let's represent that minus 1 3 with respect to, okay, we are going to represent it with respect to d. So the representation with respect to d of the image of v is equal to the representation with respect to d of minus 1 3. So that representation is going to be c1 times the element of d. Just let's recall the element of d. 1 is 0, so the element of d are 1 0 2 0. Sorry, 1 is 0 0 2. So we have 1 is 0 plus c2 0 2. So equals minus 1 3. So what we have here, c1 equals minus 1 and 2, c2 equals 3. That means c2 equals 3 over 2. So the representation there of v with respect to d, of the image of v with respect to d, is going to be minus 1 and 3 over 2. Yes, this is the same as that. Okay, so it's checked. Is that okay? And I think we are going to stop here, okay, for this lecture, the tutorial, and I will see you in the next video. We will continue with the lecture. Thank you.